is Andrii, and I'm honored to present a work we've been doing together with Myroslav, Komar, Ihor, Maykiv, Serhii, Hutsal, and Dmytro Diuh on increasing decision-making efficiency of decentralized autonomous organizations, particularly in the warehousing sector. What we've been doing so far is integrating Web3 technologies into existing Web2 systems, trying to utilize the most efficient and new approaches they give us, trying to get maximum output by providing minimum input, therefore dealing with all challenges we get and minimizing costs. One of the problems that we faced is that most projects integrating Web3 possibilities into themselves don't really pay much attention on data access. Therefore, these processes are not optimized while the system is being initiated, is being designed. Instead, these processes take place usually after MVP is released, somewhere in the end, whereas it might be too late. We've previously been talking about DAO system as a main object of the investigation. I'll briefly explain to get you into a context. The idea here is that this is an organization running and being controlled completely by blockchain technology, by tokenomics inside, that may take decisions, but where every member is an equal part. There is no central authority, there is no leader. All decisions are made all together by some regulations, by some rules. They're manageable, they're flexible, and we are utilizing this technology to improve the efficiency of decision making at all. How does the structure look? It is a set of smart contracts running in blockchain with some inputs and outputs. Each of them has their own task. Here is a structure where the governance contract is some sort of representation of the warehouse and all business processes it has, related ones, in the Web3. The object of investigation is one transaction. This is what we are trying to improve. Here is an example of what one decision should be, what is the path of a decision it has to make to be approved or not. Every single arrow here is, almost everyone, is a transaction in Web3. So one decision is supported by like 10 of them. And having all of them efficient, having all of them cheap, means having the system efficient and cheap. This is what we are trying to improve. In this table, we can see all types of transactions running here and there in DAO system with the percentage of them being used and rough gas estimate cost. What is important is that this cost is well deterministic. When we have a POC of a system we are trying to integrate, we can do some simulations to not even approximately, to exactly say how much money will it cost to maintain or to run this system with this number of users for this period of time. What are our numbers when we build POC for the DAOs that we are going to integrate to warehousing systems is that running this DAO with 50 members will cost us $9,000 per month. When mentioned ETH price is 3,000 per ETH. This is the input, this is what we are trying to achieve and to decrease. How are we going to do that? Mainly by data indexing. The main idea here is that on top of Web3 application, we are building a Web2 standalone server that is going to be listening to events, to data from blockchain, from transactions happening here and there, and that is going to be indexed and stored here in Web2. Utilizing common technologies we have like relational, non-relational databases and so on. On top of that, we are building a convenient API layer so that both automation, UIs, manual clients can use for their needs. What are the benefits? Data access is almost free since we don't have to reach blockchain to read anything. to perform any queries, any filtering, and so on. Every data is right here next to us. And this data is not concurrent anymore. We don't have to wait for a transaction to execute in order to get the relevant data. By the way, this relevancy now becomes slower as the point of truth is still data that is in blockchain. Our copy cannot replicate it completely. It sometimes may be invalid, so that every validation is still present in Web3, but it doesn't prevent us from doing some pre-calculations, pre-validations, some data display, and it's completely fine to have data being outdated for a couple of seconds or even minutes. The third cool benefit is the data is structured well. In Web 2 we purely store bytes, I would say, but in Web 2 we can have tables, we can have graphs, we can structure, index, and store data in the way we want, and we find it more and more efficient for getting or for working with it. We also have callbacks and subscriptions and so on. And interchangeable indexers are present there as well. What are the results? Well, per our calculations, amount of money that we reduce for this DAO to operate is roughly 25%. This is what we made by running our POC in simulation for the same overall scenarios that we used to design in previous our works. This table briefly shows the amount that we received. Some transactions were optimized well, some didn't. It depends on type of data and type of action that need to be executed. Overall, this research optimizes the work of Web3 DAO system to be integrated in Web 2. It suggests some techniques and methodologies to use. It provides a well-defined POC algorithm for every single Web3 system to be integrated. It makes it deterministic in terms of calculating costs with and without this optimization, so that potential clients can really know how much money will they need to spend on this DAO. And integrating into warehousing is still to be implemented. As a result, we've managed to decrease the amount of money we have to spend on DAO to be operating well by 25% per month, and the approach we've got is flexible enough so we can be integrated into every other system, even outside the warehousing area that we used as an example as a main object. And this achievement promises to have increased customer satisfaction and to position companies for a significant business growth. Thank you for your attention. I would appreciate if you had any questions.